Well, welcome everybody. Thanks for making it out here right at the end of build. We made it. Last session of the day. How many people are going to the party later? All right, people are sticking. I won't keep you too long then. We will get cruising. So we're going to, today what we're going to do is take a different approach to some of the sessions that we've done in the past at Build. We're going to look at what's new in the platform. I'll give you a quick overview of new APIs that have come out this year. But then we're going to look at some what customers have been doing with Bing Maps and show you some code that sits behind some of the features. We'll take a look at some new features and we'll also revisit some old favorites. And we'll have plenty of time for questions. And since we're a pretty small crowd, I'd say if you have a question on something that you see, call it out, I'll repeat it, and I think it's better when we have a small room like this to ask a question while what you're interested in is up on the screen. So how many of you have used the Bing Maps APIs? About half, so some of you are new, and I'll just give a quick history of what we've been doing at Microsoft with Geospatial. So as you can see here, we've been at this for about 2 decades now. More than 2 decades if you go all the way back to Encarta, but I don't know if I would go that far back and count Encarta. But it got interesting around 2004 with the MapPoint web service. That was our first cloud computing geospatial API, and we've come a long way since then. As you can see here, we have now thousands of customers around the world in just about every industry doing very interesting stuff. And we continue. This is a common question at the booth. A lot of people came by our booth this week and they're like, oh, wow, I didn't know Microsoft was still investing heavily in maps. And we really are. We're a 100-person engineering team inside of Microsoft, and we've really invested a lot, especially over the last year, in the platform and in new imagery providers as well. So you'll see some new bird's eye imagery coming into the platform this year. So when we talk about the platform, it's really 2 things that developers think about. We have our REST APIs and we have our map controls. So we have our JavaScript map control and we have the Windows 10 map control, which saw a nice facelift this year, and we're going to take a look at some of the new features there. So think of it, I'm going to show you some of the hot new features, but think of the platform as providing all of the foundational stuff that you need when you're building geospatial applications. So we have great data visualization, core mapping, driving directions, traffic, all the stuff that you need when you're building your geospatial apps. We do this in over 150 countries, and we provide great developer support. I think that's one of the things that we're known for. If you haven't worked with us yet, you will find out when you dive into our APIs. We have the best documentation, 24/7 email and phone support, and we take our developers really seriously. This is a quick look at what we've got in V8. The V8 map control is now, I think, about 2 years in market, but we've been adding to it steadily. So although it's 2 years old, it gets a facelift. New features are rolling out every couple of months. So as I said on the last slide, we've got all the basics covered here. Great data visualization, whether you're doing heat maps or shaded area maps. Traffic, clustering, we're going to take a look at how one of our customers is using clustering, one of the most overlooked features. And we'll look at map styling also, because a lot of people don't realize how flexible our map styling is. So that'll be fun to see what customers are doing with that. I mentioned the Windows 10 control. Now, if you're not familiar with the Windows 10 control, it's on every Windows 10 device. A lot of people don't realize it. Look for the Maps application, which is built by the Windows team using our map control. So if you launch that, you're actually basically running our map control. But it sits there. Our APIs are well documented for it. It's got a lot of capabilities that are just not possible over in the JavaScript control, things like the 3D buildings, offline use. I was talking to a customer this week where, I mean, that was worth gold to them. So they have a team with tablets out in the field, and being able to go offline and still take their maps with them is a great benefit. And so that's one of the new features that was added this year, is this third dialog that you see out here for offline maps. Used to be off in settings. Now it's exposed through the controls, so you can actually ask your users to download maps, they can go state by state or country by country and take those regions with them so that they're ready to go when they don't have Wi-Fi access. Some other features in that map control. 3D models is a new one. In addition to the 3D buildings that are built in, it's now really easy to import 3D models. I'm going to show you a little animation of that on the next slide. And yeah, it's kicking in here. So this is a pre-rendered video of some cars moving around, all being controlled programmatically. You'll notice in a moment that there is no collision detection. So you're on your own for that. Boom, there we go. They just passed right through each other. And for those of you that are interested in the 3D stuff in the map control, ask me about a new API after the session, because we are exposing all of the buildings. We're working on an API to expose the actual building data. It's all available right now. This is all, if you've got the Windows 10 app and you're looking at 3D buildings, it's of course streaming live. That's a lot of data. It's not cached on your device. But it streams in a proprietary format. We're going to be releasing a control that'll let you get at that data and stream it, bring it into your own applications. So if you're building VR applications and you need access to our library of 3D buildings, that's something that we're looking at releasing sometime around the summer. So we had a session earlier in the theater where we really drilled in deep on these new APIs. I'm just going to summarize them quickly here for you. One of the industries that we really wanted to shore up our support for was trucking, fleet management, and logistics. So this year, we really focused on that area. These are 4 new APIs that are in production, and I'll go clockwise and just explain them with a quick summary of each. Truck routing is exactly what you would think. Trucks can't go where cars go very often. They have to worry about things like tight turns and low bridges and hauling flammables over a bridge where flammables aren't allowed. So with the truck routing API, you can pass in all of the parameters that define your vehicle, and we will optimize the route to avoid tight turns and all of that good stuff. Moving clockwise over to isochrones, this is my favorite because it's not only very visual, but it's very useful. And the isochrone API lets you pass in a coordinate and a travel time and a travel mode. So your travel mode could be either driving, public transit, or walking, and we'll basically calculate how far from that point you can get in that many minutes. So in this case, you're looking at a 15-minute isochrone around that black dot, which is my office in Bellevue. And what we're showing here is, well, how could I filter listings? Imagine that these are real estate listings, the purple dots, and I've got a lot of them on the map, and I only want to select the ones that are not within 15 miles, especially in a place like Seattle where we're divided between Bellevue and Seattle with a lake. Crowfly's distance is not of much interest to me, but commute time very often is. So what you're seeing is a 15-minute buffer, and then we show you how to select the items which we then highlighted in red that are within your 15-minute buffer. Continuing around, distance matrix. This is definitely geared towards the fleet management and logistics industry, but I'm going to give you some insight on how one of our customers is starting to use it in real estate in a moment. And basically think of it as many-to-many driving directions calculated really fast. So you can pass in a grid of start points and end points, and we will calculate the drive time and drive distance between all of them very fast and return that to you. And the grids can be, I think, we're going up to 50 by 50 matrices. So it helps you solve things like the traveling salesman problem. It helps you optimize your trucking and logistics. If you have, say, 3 factory locations and you need to deliver to 100 supermarkets every day, well, how can you load balance that? The distance matrix API has your back on that. And lastly, we've got the Snap to Road API, which takes a series of coordinates, usually derived from a GPS device, which can be inaccurate, and you see them there in blue. You pass in the array of points, and we will snap them intelligently onto the road, interpolating between the points. So you'll notice for this point up here, it's not the closest road that it's going to snap to, but we've intelligently figured out that that was probably the route you were on in red. So we will return the red route, and we will return information, metadata, about the roads in that newly constructed route so that now you'll know the actual driving distance. We'll also return things like the posted speed limit on that road. Very important, again, in the trucking and logistics industry, where they need to often check on where was a driver exceeding the speed limit, because they know from the GPS what the speed limit was. Now they can call this API and see what the posted speed limit was and compare. So now let's jump in and look at what some of our customers are doing. We're going to start with the humble, find the nearest application, the bread and butter of our industry. But I wanted to revisit it because a lot of people don't realize that we've got some pretty interesting features that our competition doesn't have that help you build locators. In this case, we're looking at Amazon's locker locator. But in general, think about when you've got a spreadsheet of names and addresses and you want to plot them on a map. You're going to want to do geocoding. And then you're going to want to do spatial query against them. And you can do those things on your own. You could actually use our API to individually geocode all of your records. But a lot of customers start with a lot of data, and they don't want to, I've got 1 million records in my database. I don't want to call the API 1 million times. We have a batch geocoding option, which I'm going to show you in a minute, which you can upload your data to. We'll geocode it. We'll send you an alert when it's done. Then you can download it. But better than downloading it, you can leave it stored in our cloud, what we call our spatial data services, and then you can operate on that data using our query APIs. And you can do some very interesting things like not only find nearby, but finding along a route. Imagine you've got a driving route and you want to do a search for your POI, your points of interest, along that route within a 1 mile buffer of the route. That's a complex query, but we offer that service in our spatial data services, and you can bring that into your applications. So let's take a look at how you would go about building, going from having a spreadsheet of data and how you would build a basic locator application. So I mentioned spatial data services. These are some of the features that it has, and I just rattled through these. The most important for what we're discussing right now is the ability to upload your data and store it in our cloud, but then also down here you've got the services to query it and the batch geocoding up here to the one-timer to get lat longs assigned for your data. So how do you do this? You go to our portal, bingmapsportal.com, and you choose the Create New Upload Data Source menu option under Data Sources, and you'll get a screen like this that you see on the left. And you give it a name, you specify your file format. You can see we've got all the common ones covered, including KML and Esri shape files. So you upload the file to us. You would probably not select Publish Without Geocoding, and that'll tell us to go and geocode the data. So there's probably a practical limit on the file size, but I know customers routinely upload tables of over 1 million records and get them geocoded. When the geocoding is done, like I said, you can download your data, but we also give you a little visual editor so that you could review your data point by point. You could correct for a bad geocode. You can even edit the entities, and you'll see down here per entity. You can have other fields besides the name and address fields that we need to do the geocoding. In this case, when I uploaded this sample data, I had a field called YPID and a business name, and those carry through, and those will be available downstream when you do your spatial querying as well. So once you've uploaded your data and created your private data source, now you can query against it. And we have a lot of different query capabilities. Like I said, the most common is find the nearest, where you pass in a point and a radius, and we'll hit your data source and return the records that are within that. But then also bounding box and finding along a route are very common. And the query is very simple. The only thing that you would change here is your data source. You would change that to be your own private data source. You'd set up your query options. In this case, we're going to do a find nearby with a radius of 5 miles, where you can see that you can do filtering against attributes that you had in your data. In this case, I had one called entity type, and as you can see, entity type 5540 is gas station, so I only want to see gas stations that are within this query. I get my query option set, and then I fire it off. And in this case, I'm going to just take the results and slap them right into a layer with one line of code so that they appear on my map. Nice and easy. And that's really the core of a locator application. So LinkedIn is doing some interesting things with some of our newer APIs. One of my favorite features is, I sort of described it to you a moment ago, but it's a query based on commute time, filtering results based on commute time. So I know where I live, and I know I don't want to travel more than 30 minutes in the morning when I'm considering new jobs. So LinkedIn will now use that isochrone capability to filter their job listings so I can play with a slider and move it up and down and see how many more jobs appear if I'm willing to travel, say, 10 more minutes while I'm driving each day. An interesting thing about the isochrone API that I didn't mention, it also can consider real-time and historic traffic. So based on time of day, I can pass that in as a parameter when I'm generating my isochrone, and we will consider real-time or historic traffic. So if I passed in 9 a.m. tomorrow morning when I'm generating my isochrone, and I say I want a 15-minute drive time from downtown Seattle, it might be this big, but then by 2 p.m., the shape might grow, and I would be able to drive farther. So it's very important when you're doing something like what LinkedIn is trying to do. We typically know what our commute times are, or when we want to commute to work, so being able to pass that in has a huge effect on the results that I get back. And yeah, now we're just seeing that visually, what I had described earlier. Lots of job listings, filter to job listings within 15 minutes. And how simple is that to do? Really simple. I'm going old school here in building the REST URL where I'm saying, hey, I want to go travel mode is driving. The waypoint is going to be the center of the map, so imagine that I've just dragged my map to where I want to originate my query. I grab that waypoint, add it onto the URL, and then I grab max time from a drop-down of, say, 15 minutes, and that's it. I fire that off. We will return the actual geometry so that you can draw it on the map, but more importantly, you can then do interesting things with that, like spatial query filtering. One customer just started using this feature where they take the results and they don't even display it on a map. They're using SQL Spatial, and they just pass the coordinates back into their SQL Spatial query to filter the results down. So that's pretty slick. And then how would you then use it if you were client-side in, say, JavaScript code? You wanted to filter pins like you just saw previously. We had all those purple pins. We want to highlight just the red ones that are within the polygon. Our spatial math library has a ton of great functionality. This is often overlooked by developers, so I did want to draw it out here, but you can see the path to it. There are so many good functions in there. Polygon geometry, intersecting unions of polygons, intersections of polygons, querying for things contained within, boring holes inside of polygons, straight line distance measurement, a whole bunch of stuff is in that library, so definitely check that out. You can see how it's being used here to say, okay, I've got all of my pins, which I just grabbed from my pin layer, and with one line of code, I could say, I've got my search area, which represented that polygon, and I want to get a list of pins back, the intersecting pins that intersect that search area, and it's that simple. Then I can, as I'm saying down here, now I can iterate through them, I can draw them differently on the map, or put them in a list view, or whatever I need to do with those results. All right, so this is another new API, the Location Recognition API. And it builds on a concept that we've had in our platform for a long time of reverse geocoding. Reverse geocoding, and for those of you that are new to that term, first I'll define geocoding. Geocoding is generally taking something in plain language, plain English, and turning it into a coordinate. 22 Main Street, Philadelphia, Pennsylvania. Well, what's the coordinate for that? I geocode it, and we return the coordinate. Reverse geocoding goes the other way. Now I've got a coordinate, and I want to know, okay, this is a coordinate somewhere on the globe. What is there? What's the name of the city? What's the street address? Is there a business there? Is it in the middle of a lake? Is it at a landmark like the Space Needle or an airport like SeaTac Airport? What's at this coordinate? So we combined all of that into one mega reverse geocoding API. Our existing reverse geocoding API only returned the street address information and the other geographic hierarchy information. But this API now combines all of that into one. It also uses a little bit of AI to understand based on, again, you could pass in time of day, and it'll try to figure out, well, what business do they really mean? Using some machine learning, you can figure out things like, well, at 3 in the afternoon in this strip mall where there's a doctor's office and a pub, maybe 3 in the afternoon, it's the doctor's office. But if it's 8 p.m., it's probably not the doctor's office and it's the pub, so that'll be ranked higher in the results. So the SwiftKey, the popular keyboard, this company was acquired by Microsoft a couple of years ago, I believe. They started using this API. They were one of the first internal customers of it. And you can see what they're doing is, as I'm typing, hey, I'm at you don't have to type anymore now. You'll get real-time suggestions. They grab the coordinate from the phone's operating system. They pass it to the location understanding API. And now you can just click and say where you are. So this is just came out in time for build. We just announced this on our blog today. It's in preview, and it's just between us here in this room, it's a pretty liberal preview because it's really there. We just didn't get the documentation and some other stuff buttoned up. So we said on our blog something, Angela, keep me honest, I think we said it'll be available by summer, but it's really available. If you look at our blog today, all the documentation and everything that you need to start using this API is actually there, but it's called preview because it wasn't fully documented and ready to go in time for build. And here's a look at how simple it is to use. There's really only a couple parameters, and here I'm just showing the coordinate being passed in, and of course your Bing Maps key, which if you don't know how to get a Bing Maps key, I'll show you that at the end. And then this is what comes back. So we got two big blocks that I'm showing for this particular coordinate. It looks like we're down around SeaTac Airport. So I've got the address, and this is the top business listing that came back, Doug Fox Parking. And you can see the address and everything for Doug Fox Parking. And then out there, you see the other block, and that's the address location information. And there is one parameter that you can pass in here if you don't need the business information and you only wanted the address information. It might save a couple of milliseconds, but there is a parameter that you can pass in for that. So here's another great application. Onterra Systems is a partner of ours. They've been building route optimization systems on the Bing Maps for Enterprise platform for years. And they just added a cool new feature that's in beta for them right now. And it's based on our fleet tracker. And if you were at the session earlier, I did a theater session at 2 o'clock today showing the fleet tracker. I'm going to show it to you now quickly, but I won't go into as much detail. And what RouteSavvy is doing with that, they have a lot of customers in the trucking industry that go to them to do route optimization, delivery optimization. What they've added now is the ability to see where your trucks are in real time as well, which is a huge, huge feature for them. So they take advantage of, and I think I just mentioned that it's open source. So we released this fleet tracker, which we'll look at as open source. So they took advantage of a lot of the features that we built in that open source release. This one's really nice, the ability to just pop a QR code up in the dashboard, load the client application on the driver's phone, and then they shoot this QR code. Now they're tied to the back-end system, and that client application will keep shoving location up to the server with very little code or effort on their part. And here's a look at our dashboard. So this is what we released that Onterra Systems took the source for and integrated into their existing trucking solution. I'm going to switch and give you a demo of this now, but the important point here is we released everything that you need, soup to nuts. We released the client applications for iOS and Android, the source for those. They're also compiled on our GitHub, so you could just grab them and start using them if you want to experiment, but the code is there so you can go in and do tweaking or just talk to a number of customers today that really don't want our application, but just want the location tracking portion of it, because there is a lot that goes into that. You've got to be battery friendly. You obviously don't want an application that's going to run down the driver's phone battery in a day. So we put a lot of care into that in both the iOS and Android versions. But you can go and grab just the chunks you need if you have an existing mobile application and build that in. And then we, of course, included the Azure backend, which includes this web dashboard, as well as all the services and the database that you need. So it's everything that you need, one-click deployment, and you're up and running with this solution. And Ontera then took the chunks that they needed and built it into their application, saving them many person-months of coding to bring a really high-end feature into their route planning software. So let's switch over and take a look. If you were here at the beginning, you probably saw my colleague Eric down here. We were looking at this map. This is our dashboard. This is my private deployment of the code, and you can see I've got 3 of my colleagues have been added in. This is Eric in San Fran. That's me up there in Seattle, and Justin was kind enough to turn this on when he was in New Orleans for Mardi Gras, and we got to watch him have fun, and we kept track of him, watched him run around the city. So that was fun. We'll zoom in here on Eric. Let's see if he has moved. He was at the mall earlier. I told him to go and drive around while we were doing our sessions today, and he did, which was very kind of him. He's either still at the mall or he just hasn't moved. That timestamp is now over an hour old, so I don't know if he turned his phone off when he was there or not. So you're seeing that the most basic feature is just being able to see the point of where everybody is, but I can also look at trails, historic trails of where people have been. I'm going to choose my phone and give that a second to load. There's, as the GPS points are rolling into the system, oops, let me zoom way out. A service runs in the background and does the analysis. And what it's determining is, let's get some data in there. It's determining where I've stopped, and it considers that a new location. And it also figures out, well, what are the contiguous points that actually make up a route? And it will log, create a new trail for me, and you'll see that in the reporting. And it looks like I'm not getting any data loading here. I'm not sure why, but I should. I've got my internet access. All right, no points. Sorry about that. Maybe we'll come back and try that later and see why. Well, there we go. Looks like we're having some kind of problem hitting the server. My internet looks good. All right, well, we'll come back to that. Let me show you some other features in here. One of my favorites is the geofencing. No, we've really lost our internet. I think that's like when you're out at the bar at the end of the night and they like throw on the really bright lights, and that's what's happening right now at Build. They turn off the Wi-Fi and then they're like, all right, you guys get out of here now. I don't know. We'll see if it comes back on. So I'm going to switch back so that we don't waste time looking at an empty screen and having me describe what would be happening if things were working. We'll get back there. So how do you get started with the fleet tracker if you want to deploy this on your own? We've got everything up on GitHub. You can download the source code, compile it, and deploy it yourself. Or you can take advantage of our one-click deployment portal, which I've got open so I don't have to worry about the internet not showing it to you. But this is our GitHub. And if you're taking a picture, I've got a slide that'll give you all the URLs in 1 second, and you hit that slide. But this is where you can download from, and if you scroll down here, this is where you'll get a link to the one-click deployment portal. And all that's doing, it takes all the source code for you, deploys it to your account, just saves you a little bit of time. And you can see in my previous demo, that's what we were doing. We were creating a new deployment. You come to this portal, sign in with your Azure account, choose your subscription, enter your Bing Maps key. If you don't already have a Bing Maps key, go to excuse me, the Bing Maps portal at bingmapsportal.com and sign in with your Microsoft account and get a key, paste it in there. It's free to do so, and you get 125,000 transactions per year for free. So there's no cost in trying this out. Fun thing to do, just go and deploy this. I was just talking to one customer after the last presentation. He's like, I want to go home and make a family tracker, because we all have, we're on the family plan for cell phones. We have 4 cell phones, so his kids don't know what's about to hit them. So that's a fun thing to try out. But anyway, you get everything set, you hit deploy, wait about 10 minutes, you get a little wait cursor, and then boom, you've got your dashboard up and running. You just take the compiled application, put it on your Android or iPhone, shoot that QR code, and you are up and running. All right, moving on to our next API and our next customer, Zillow, the real estate company. They do some pretty innovative things. For one, they use our map control in some cases. They've also built their own map control using our static imagery API, which is kind of cool. It's a lot of work on their part, but they had reasons that they wanted to do that. So they're a very interesting Bing Maps customer. They do a lot of very unique things with us. So we're going to look at 2 things that they do in their application. Number one is they have a custom map style. So out there, you can see our default map style, and you can see what they did with their color scheme. They softened the water. They said, oh, we want our data to pop on the map, so we're going to flatten everything out. We're not going to highlight roads, major highways in green and purple, and that's just their corporate look. That's the personality of their website. Really easy to do. We'll show you the code that does that in a moment, and it really makes their data pop. And it's kind of subtle, but you can do much more extreme things, which I'm going to show you on the next slide. This little animation will show you some really ugly and some good-looking maps. I'm not responsible for these styles. Some of them are, like, that one's pretty ugly. Get a nighttime map. I like the black and white map. Depending on what you're doing in your application, you might want it to match your corporate colors, your college colors, whatever it is you're doing. It's very easy to customize just about everything. I like that one for certain uses where you really want everything to drop out and you just want to see the land masses. And I think that was the last one. Yep. And so this is something that's plagued us for a while, and maybe this is why a lot more people aren't using styling. We do not today provide a good style editor. Everything is customizable. But we don't provide you a good editor. So that's another item that I'm kind of pre-announcing here. We're working on that right now. We'll probably just release it as open source, let you go in this little application, tweak your colors, hit export, and it'll basically export the code that you'll bring into your application. So you can see here that, and this is not a full list of everything that you can customize, but I just wanted to show you how easy it is to change, say, the road fill color. Or the strokes of railways, et cetera. So every element in our map has a token, and you can change its style just like that. And typically what you'll do is, this was done at the beginning of an application before the map initializes, and you can see that when the map initializes here, I just pass in my style, and boom. All of our map tiles are rendered dynamically on the fly, and that's what enables us to basically let you do any kind of styling dynamically. And then the other interesting thing that Zillow does is, and a lot of people think that this is so complex to draw complex geometries on the map, but it really isn't. There's 2 ways I'm going to show you to do that. What they do on their site is when you zoom in to a certain level, I think it's down to the last 2 zoom levels, they turn on all of the property boundaries, because if you were to zoom out, you don't want to draw all that. It would just be too much data. So when you're down to the tightest 2 zoom levels, they turn this on. There's really 2 ways that you can do that. The first that we're looking at, we added this summer, and this is our support for all industry standard geospatial file formats. KML, GPX, GeoRSS, and a bunch of others are all supported. And if you have your data in one of those formats, it's now, you used to have to write hundreds of lines of code to import KML. I see some nodding. You may have actually done that. it's a lot of work, and there's a lot of quality assurance in doing it because the KML spec is so huge. But now with just 2 lines of code, you're bringing in a KML file as a layer, and all the items that you've brought in are all interactive. So that's the simplest way to do it. But then many times you'll have your data that makes up, like in the case of Zillow, they've got all of their polygon data in a database, not in a KML file, so you want to draw it programmatically. Also, just as simple. Here, I'm just showing how to draw one simple building footprint with just 4 coordinates. So it's nice and simple. You've got great access to all of the styling. And that's it. That's how, imagine iterating through a loop. You'd probably want to be smart, put all of those shapes into a layer, turn the layer on and off at the correct zoom levels. But that's the core of how simple it is to draw polygons on the map. Ohio DOT, they're using one of my favorite features. I mentioned it earlier. It's so overlooked. And this is another one where, if you've built any type of mapping application where you're drawing lots, high density of push pins, if you've managed them yourself, it's a lot of code. So you don't want to overwhelm the map by drawing 10,000 points. So what you want to do is cluster them. And when I've written code like that in the past, you use pixel distances, and if you've got a bunch of points within some pixel tolerance, you roll them up into a grouping item, which you can see here on the screen. The push pins that have numbers are telling you there's a 15 in the middle. That means there's actually 15 items there, but they're rolled up into one, and they're too close together to show them efficiently. But as you zoom in, you'll then unpack those 15 items and draw them individually. So it's a lot of code to write and manage a layer of push pins like that. So now we've made it this simple. Well, yeah, there it is. It's this simple. The first line of code is really just a test data generator, and it's going to randomly create 1,000 push pins. So that's a test generator data class that we have that helps you when you're building and debugging applications. But now you can see that when I add them to a cluster layer instead of a regular layer, that's all I have to do. Everything else is done for me. As I zoom in and out, we'll unroll and roll up the pins, and you can see my example here. I had 2 pins, I zoomed in, and then they pop out. And they have all of the attributes of regular push pins. So all the data that you wanted in your pop-up window all comes along with those pins when they unpack. And that is it. I'm going to pop back now. This was the slide that now you want to take a picture of this one. So this is, if you remember one URL, it's this one. This is our developer center. You go there to basically do everything from get your API key. You have links to our documentation, links to the interactive SDK. I'm going to click on a couple of these right now, assuming that my internet is back up, or I'll switch to the other Wi-Fi and get something going. But it's that first URL gets you basically everywhere, including our marketing materials, documentation, sample code, all that good stuff. And yeah, let's leave that slide up and switch back and see if our internet got any better. No, well, there is the demo Wi-Fi, so I'm going to switch over. If you guys can just tolerate me typing in a password here when I connect to this different demo Wi-Fi. All right. Excellent. Perfect. So now we'll just back up a little bit. I'm going to show you how to create a geofence. So what's a geofence? I've got my fleet of trucks or drivers moving around. I'm going to define a geographic area, and I want to get an alert whenever one of my drivers enters or leaves that area. So you can see here I've got one geofence that I had previously created, but I'll show you how to create a new one. And here we are. Let's go downtown right about to where we are. Yeah. And I'm going to block out this whole area. All right. So I give it a name. I can put some emails here of who I want to notify. And again, remember, you get all the source code for this. So the way we ship it, we work with an email provider. Whenever a fence is triggered, you'll see what happened, where you can cut in the code and do whatever you want, send a text message or log it or do anything. We fire off an email in this case. Cooldown period is interesting. It's so that if the GPS is right at the edge, you don't want to keep over triggering if someone is going in or out or is right at the edge. So that's how much time between alerts. So after I come in the first time, I won't send another alert if the user leaves and comes back in within 3 minutes. So that's a convenience feature. And then I can say, well, do I want to have it trigger when someone enters or when someone leaves? I'm going to say inbound in this case. And I'm going to choose 2 assets. And that's it. I now have, whoops, let me click on that. I've got a new geofence created. Now what would make for a really cool demo, maybe we'll try to synchronize this next year, is if we sent someone out and actually had them run around with a phone and we'd get an alert that, that they had entered. Could have had Eric doing that on our behalf. And so yeah, I'm glad we were able to get that up and running so that we could show you that. And then the last thing I was going to show you is our interactive SDK, which was one of the links back here. And if you're new to our platform, this is a really great place to start after you get your API key. Come in here, and basically for every bit of functionality in the map control, you will find a nice, concise code snippet. So you start with the most basic. I just need to load a map. Not very glamorous, but there it is, nice and simple, 1 line of code. And then it gets gradually more complex. Custom map style upon loading, bird's eye imagery, and you always have your code right down there, and you can clip that into your own applications. And then like I said, as you scroll through there, you'll find everything from heat maps, great data visualizations, everything. And this isn't a replacement for our full-on documentation of the platform at MSDN, but once you're kind of familiar with the platform, most developers just pop in here and find exactly what they need and skip the documentation, but they complement each other pretty nicely. All right, well that is everything that I had. So now we can open it up to questions, and I've got some prizes up here for questions. They don't have to be good questions. You get a prize for asking anything. And the prize is, we're giving these out at our booth this week. They're travel chargers, or travel adapters, international travel adapters. So if you're hitting the road soon, heading to Europe or South America, ask a question. Yeah. Yes, you can have altitude, and as a matter of fact, someone's happy about that. Yeah, so not only is there altitude, but depending on what you want to do, over in our 3D map control, you can, we had one demo that we were showing at our booth where you can import a GPX file that's got coordinates with altitude, and we'll put it properly onto the ground overlay, and tilt in 3D. It looks really nice. So yes, we support altitude. Oh, you want to catch? There, it's not that heavy. All right. Those people in the back, though. Test my arm. Anybody else?
Is there anything that the JavaScript control can do that the Windows 10 control can't do?
Yeah, so the question, to repeat the question is, what are the major differences between the JavaScript control and the Windows 10 control? There's quite a bit. Over on the Windows 10 side, the APIs are similar. We tried to make them look as similar as possible, but they're different. The platforms have such radically different capabilities. Like we did at some point back in the mid-2000s, we tried doing 3D in the browser, and it was very interesting. We were able to get it to work, but it wasn't great. So that is much better left to native code. So that's one of the big differences is you get that type of capability over in the Windows 10 control. The JavaScript control has built-in truck routing for one. Now you can call the REST API over with the other control and then overlay your truck route, but the JavaScript control has a lot more of this built in. So basically it becomes more of a convenience. So that's one that comes to mind. And there is a page in our documentation that actually compares them. So instead of just testing my brain on which ones I remember, if that's important, go to the MSDN documentation and you'll see those compared and contrasted. But get a, ready?
Are you sure?
Yeah, I can reach you, I know that. All right. Anybody else? Great question, and that just that came up earlier, and it's almost like I read your mind because I just passed that feature request on to our engineering team just before this session because another person was asking about it. Specifically, they were asking about avoid areas and being able to put a cost on certain road segments. So, and being able to define an area to avoid in routing is really just putting an infinitely high cost on it. We used to, for those of you that have been using our platform for a long time, we used to have a CD product called MapPoint 2000X and Streets and Trips. And they actually let you draw a box on the map and then right click on it and say, avoid this area for routing. And it basically, for every road segment, it just put an infinite cost on each segment so the routing engine would basically avoid them. So that was a very generalized case of what you're asking for. We've had people ask for it because another case of it is avoiding tolls. So toll roads have a higher cost attached to them. But some companies would like to say, hey, for the type of trucking or fleet management we do, we want to put a really high cost on this certain class of road. We don't support that right now. But what we are going to take a look at is at least being able to set an avoid area, because I think that is a useful feature, to be able to programmatically draw a box on the map and say avoid this zone, I think has a lot of value. So we've already noted that feature request. It's not something that we've got right now. Ready to catch? Whoa, all right, that one went a little bit high. Yeah. Yep. Yeah, so let's break that apart because we do one part and not the other. So the application code that we've got will, if it loses its connection, it's still acquiring points and it will upload them when it's got connectivity back, but we do not support on mobile devices offline maps. But that means that you can still be tracking where you are. It's not going up to the server in real time, but the device is remembering it. And then when you're back in a connectivity area, all those points will be sent up to the server. So you'll eventually get that route up in the server, but we don't support offline mapping. That's another good feature request. We've actually, in the past, we had dedicated map controls for iOS and Android that did work offline, and we are considering bringing those back to market, but we don't have them yet. Oh, low throw, good. Yeah, question. Yeah. are you saying, would you be able to use a dedicated, like, Yes. Yeah. And that's, again, that's the advantage of us releasing this as open source. When we released it, the way we ship it is phone uploading to an endpoint, and then we do all the fancy stuff that we just showed you with geofencing and trip determination. But it's real easy to go into that code and say, okay, I've got a different source of real-time GPS information. My fleet already has commercial GPS hardware, and I'm sending location. They send location up to a service. You can write code that then takes the locations as it comes in and send it to our REST endpoint that would be on the service that you've deployed. So it's real easy to bring other sources of real-time location information into the solution that we showed. Nice. What else? Explain what you mean by standalone maps. I got it. So you're saying, and that's the case with the Windows 10 control where you can download and work offline. Someone asked that question earlier also, so it's a good question. When you load the map control, that's considered one transaction. And so that would be your billable transaction, whether your data was offline or whether it was streaming. So you've got one billable transaction to load that map control. And then you can do a whole bunch. You can pan and zoom and do driving directions, and that's all within that session. So that's considered one transaction. It doesn't matter if your data is offline. And since you've asked 2 questions about offline maps, I know that's important to you. And I know I mentioned that there's a new feature where that control, the dialogue can now come up programmatically within your application, asking your user to, hey, what areas do you want to download? But I should have mentioned, because one of my teammates mentioned to me today, gave me a reminder, that can actually be controlled by an administrator. So if you've got, let's say your whole company works in Connecticut and New Jersey, so every device needs Connecticut and New Jersey, an admin can force Connecticut and New Jersey to be downloaded. So we've got that capability as well. Oh, I threw that one short. That's my bad. My bad. All right, we got one more to go, unless you've got some others. Last question, or at least the last question that's going to get a special prize. Anybody? All right. Well, does anyone just want a charger, a travel adapter? All right, well, thanks, everybody. I really do appreciate you sticking around this late at Build, and enjoy the closing party tonight. Yeah, I'll pop the URL back up there one more time because my email, nope, my email is not on there, and I should have it on there. My email is stevelum@Microsoft, STEVELOM @Microsoft.com, and if you have any questions at all on any of what we talked about, or you need some follow-up info, definitely reach out. Glad to help. All right, thank you.